on the screen you will see the properties of isosceles trapezoid. Okay, so what we're gonna do now next is we're gonna go back to OneNote and click on the link for kites. And now we're gonna look at the properties for kites. Here we go. A kite looks like a diamond, right? Yeah? Except that the tails are longer. Yep. Okay. So let's take a look at this. Let me write down the properties over here. Now, normally we begin with parallel sides and congruent sides, right? So, oh, DM. Where can I find this? Oh, it's in still in week number 7, special parallelograms. Yeah. Okay. All right. So, first one is okay. If you take a look at the sides, there are no parallel sides, right? But the red ones are congruent, the blue ones are congruent. They're not opposite though. So what do you call two sides that are right next to each other? So two pairs of what? What do you call those? Show off. Okay, so two pairs of what? What do you call it? If they're like right next to each other. Two pairs consecutive. Very good. So two pairs of consecutive. Some people call them some people call them adjacent. That's fine. So two pairs of consecutive congruent sides. There you go. And by that we mean the ones, here on top, they're congruent, and then the blue ones for the tails are also congruent, right? Okay, number 2. Let us show the diagonals. Look at that. Are the diagonals congruent? I think this is like a parallelogram in which one diagonal is longer than the other, right? So there's not really like special relationship between the diagonals. Okay, however, I'm going to highlight ABC right here with this as a diagonal. And I'm going to reflect that triangle about AC. Ooh, look at that. Okay, so this diagonal splits the kite into two congruent parts, right? Yeah, but does the other diagonal do that? We'll see. Here's the other diagonal. Since the tail is longer, see what's going to happen. It doesn't fill up the tail entirely, right? Okay, so this is the only special thing about the diagonal. It has one diagonal splits or bisects the kite. Oh no, the kite into two congruent triangles. There you go. So one diagonal splits the kite into two congruent triangles. And they're congruent because of side, 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 right? By SSS congruence. You'll probably need that improving later on. Because you have the reflexive in the middle, and then one pair of sides for the red one, another pair of sides for the blue one. Alright, so that's the diagonal. Let's go back to show additional angles right there. Look at that. What is this? Okay. As you can see, only these two are congruent to each other, so it only has one pair of opposite angles congruent, because as we saw, the diagonal only splits it into one pair of congruent triangles. So maybe I should write that down next because it's related to that. So one pair of congruent opposite angles. Okay. And now let me click back on the diagonals. Oh, and this is where you see a lot. Okay. Chat All right, honey, you know the Schoology thing, right? Yeah, so you have to do that. Okay, so for number four. Okay, sorry, my little one is throwing tantrums, but oh well. Just like with LeBron James, tune out of the noises around you and focus on your goal, right? Just go, go, go. Okay, so for number four, um, I just got there. What did I miss? Like three-fourths of the lesson, honey. Okay, so you have a progress check in Schoology. You have to do that later on, Nico. And then I'm on the last portion of the OneNote, but I did a screencast, so maybe he can follow the screencast later. Okay. And you missed my kids' tantrums too. So alright, so for number four, if you look at the diagonals, look at that. Ooh, what kind of angle you see in the middle right there. Okay, so let's write it down. Right, very good. So diagonals are perpendicular. Very good, Maggie. They form a right angle. All right. And look at this. 41, 41. 18, 18. Earlier, these were the angles that were congruent to each other, right? But here, look at that. Okay, the angles were not congruent, but they were split evenly, right? So diagonal, one diagonal only. One diagonal bisects one pair of congruent angles. There you go. All right. So the diagonals of the quadrilaterals, especially for trapezoid and kite, are important because once we get to that chapter on areas, we will be using them to compute for areas. Yep. Okay, so that completes our set of quadrilaterals, right? There's three main groups: the parallelograms, the trapezoids, and the kite. Under trapezoid, you have an isosceles trapezoid, but under parallelograms, that's the most special group because it has rhombus, rectangle, and square underneath it. Yep. Okay, so what we're going to do is we're going to get started on that. I have to clear the ink. We're going to get started on that other progress check in Schoology. If you guys could go into that right now. And I want us to... Wait, how do I go back to that one? Okay, yeah. Week 7. Here, progress check special parallelograms. It's not due until next week, so don't feel so pressured, to finish it in one seating. This one has 28 points, so I'm giving you like over the weekend also to work on it. It's a mix of multiple choice, and if you look at the bottom, they're all proving. So I thought that, we want to get started with that proving already, like right now. Yeah? Can we do that? Can we go backwards and start in the proving? Okay. All right. So how do I... Oh, and this is disabled too, so I have to like enable. Well, how do I do that again? Here, settings, enable. Okay. Oh, this kind of proving, you don't have to like. No, this one is more straightforward than the ones you previously did. Yep. Let's see. And I tried to kind of scaffold it by um look, I put the statements and you just have to provide the reasons. Is there a way that I can like jump from, so it doesn't let me like, if I click on, can I click next page without answering that? Okay, sure. Next, next, click on next, some more, next. Okay, that number was, I think, 8, right? Proving starts with 8, if I'm not mistaken. This one is matching. I think the next one is proving. There you go. Okay. All right. And just like in Delta Math, when you have that option, you have that drop down menu. I can't do it here in Schoology, but I tried my best of, like writing down some possible answers here and some distractors too. Yeah? Okay. All right. So let's try this. So the very first information, what are you going to put there? It must be, yep, of course. Um, does it allow you to look? Oh, there, that's so cool. I thought like you had to type in the whole thing. Okay. But can you do it as well? Have you tried it? I just know how to create it, but I don't know like how to take it. Okay. So number 2. So we know already that JKLM is a parallelogram, this one, and JH, which is this side, is congruent to HI. That's HI. All right. Number 2, angle MLK, where is MLK, is congruent to angle J. So this is MLK and this is J. Why is that true? And that's inside the parallelogram, not in the rectangle. So think of parallelogram. What are the properties of parallelogram that describes opposite angles? What should it be? What can you say about opposite angles of this smaller parallelogram right here? What are you going to pick? Yes, that's correct, Adrian. So for number 2, opposite angles of a parallelogram are congruent. There you go. Okay. Next. J, angle J. Okay, this is angle J. Let me shade that in. Is congruent to angle, what is it? Angle I. So this is angle I. Right, because that's L. So sorry if that's confusing, but this is I, that's L. All right, where do we find this? It's number 8 of the progress check in week 7. The last progress check, yeah. So just, does it let you jump from one to the other? Not sure, but okay, cool. All right, so what's the reason for this one? This time, it's not in the parallelogram. These angles are in the triangle. So you're going to find something that tells or that gives you a property about angles of a triangle. What could that be? So what's the relationship between the blue things that I put braces on and the red angles I just shaded? What's going to be like the answer to that one? I know it's long if you type it in the chat, but if you know the name of the theorem, go ahead, write the name of the theorem, but you don't know. Okay. Oops, DM. Two sides of a triangle are congruent. Yeah, this one. It's actually the base angle theorem, or it's called base angle theorem because these two base angles are congruent because the two sides of the triangle are congruent. So click, and then this long thing that goes in there. Oh, and that looks funny now. Okay. Alright, so if two sides of a triangle are congruent, then the opposite angles must also be congruent. Okay, now what? So in number 2, you have an MLK is congruent to J, but J is congruent to I. So then what happened? So they dropped this J guy here, right? They dropped that one and made these two congruent to each other. So what property is that? What property is that? It's like if A equals B and B equals C, then you drop this common thing over here and you combine A is equal to C. So what property is that? Transitive. Very good. Yep. Okay, so let's oh no, how do I do it again? I click on this and then transitive. There you go. Okay, and next page. Yeah, next page. I keep trying to drag it. Yeah, I don't even like know, right away how to do it. I was like, how do you do it again? Yeah, me too. Okay, here we go. Next page. All right. Okay, let's try this. Maybe we could, yeah, this will be like the last one we could do. So LMNO is a parallelogram. So we all know what to put there, right? That's given. Uh-huh. Thanks, Maggie. LO is congruent. So this is LO. LO is congruent to NM. And then LM is congruent to ON. That's kind of obvious, right? Because they're all sides. Perfect. Yep. They're all opposite sides. So there. Okay. Oh, you just click on it because it automatically goes to the next one, huh? All right, next. Angle L is congruent to angle N. So what is that? L is congruent to N. Opposite angles. Very good. So opposite angles. There. Okay, so now you gotta look at the three triangles. It says, three triangles? Like two triangles. Triangle LMO is congruent to NOM by what? So what's the pattern that you see here? Boom, boom, boom. What's that? What pattern is that? SAS! Alright, I was about to type SAS. Oh my gosh. Okay, here we go. Oh, does it work if I type it in? Oh no, it might mark it wrong. Never mind. Okay. There you go. SAS congruent. Okay, so that's how your proving's gonna be like. Alright, so for your weekend homework, you guys have to finish these, right? There's 12 questions, but worth 28 points. We will, I gave you 2 attempts, yes, but if you want to wait till Monday to use your second attempt, if you have questions, then feel free to do that. We will also start with like chapter review on Monday, and we'll have your test next week. So just be ready. Depending on how Monday goes, we'll have your test on Tuesday. Yeah, does it show what we got wrong once we submitted? That's a good question because the other type sometimes it shows, sometimes it doesn't. I'm gonna double check. Leave. I always enable it, but some students come back and say, Miss, it doesn't show. I put here yes. Uh-huh. So hopefully it does. Yeah. To be honest, I'm also like guessing when it does and when it doesn't. I know, right? Anyway. Well, if you have any questions, you know what to do. Picture, remind, yeah, so I can try to help out on my phone. Yeah. Sometimes I send like a voice recording. I know, right? Okay, and for those who were late today, I am going to send you this screencast. Okay? Alright guys, I won't see you until next week. So happy weekend.